Okay, today is section 7.2, and we are going to do similar polygons. And you should see a direct tie to what we did yesterday with proportions. Just FYI, you're going to hear some funky things. It's from my clock, but I'm just going to record right over it. Okay, so similar figures. The symbol for similar is like the little wavy line, which is the top part of the congruency symbol. Similar figures have the same shape, but not necessarily the same size. If two polygons, I'm just going to abbreviate it poly, two polygons are similar if two things are true. If, first thing, corresponding angles, again I'm going to abbreviate, corresponding angles are congruent, and oops, I'm off my paper. Excuse me. And where am I at? And the second thing is the lengths of sides are proportional. So there comes in the proportions that we did yesterday. Not proportions, are proportional. Oops. Oh, good grief. That'll drive me nuts. Ugh, still looks terrible, but are proportional. Okay. So if you know that triangle RST is similar to triangle MNP, then, now if you recall from algebra, when you had them in order, what they were congruent, you had some very special relationships, just like this. So angle R is congruent to angle M, angle S is congruent to angle N, angle T is congruent to angle P. That's if and only if you already know that they are similar. Also, segment RS is proportional to segment MN. That should have the same ratio as segment ST is proportional to NP. And that should also equal RT, which is proportional to MP. So no matter what, all of these three ratios, or however many sides you have to your polygon, have to have the same ratio. If they do not, then they are not similar. If we are talking about scale factor, that is the ratio of corresponding linear measurements. So in other words, the sides. Okay, so if we go back up to this example, let's say RS was 4 and MN was 2. Then it would have a scale factor of 2 to 1. Or you can also write it as 2 to 1. If we were comparing the scale factor of triangle MNP to triangle RST, that means all of these ratios would be upside down. So instead of 2 to 1, it would be 1 to 2. We'll talk a little bit more about that in a little bit. So if we look at triangle ABC, and it has measurements of 15, 20, and 25. Make that a right angle. Okay, so the first thing I'm going to notice is that all of the corresponding angles are congruent. So these angles are congruent, these two angles are congruent, and then finally the last two angles are congruent. So based off of this, I can now check to see if sides are proportional. You have to use the corresponding side. So if I look at the side opposite the 2 ticks, I have to compare it to the side opposite the 2 ticks. That should equal the side opposite the 1 tick over the side opposite the 1 tick, and that should equal the side opposite the 90 over the side opposite the 90, which is 10. So if I look at this and I simplify every one of these fractions, 3 goes into both of these, and that gives me 5 halves. 4 goes into both of those, and that gives me 5 halves. And 5 goes into both of those, and that also gives me 5 halves. If you do not have the same ratio, then they are not similar. Because all the angles are congruent and all the sides are similar, there's that stupid clock, then I can say that triangle ABC is similar to triangle XYZ. Pay attention and make sure you have correspondence. Let's do some examples. So example 1. Are they similar? There's 2 parts. And thank God that stopped. We'll do it again here in a minute. Okay, so again, we have to pay attention to what we are doing. Remember from last trimester we had the rule that if 2 of the angles are congruent, then also the third angles are congruent. So all the angles are congruent. Now we have to check for proportionality of the sides. So the side opposite the 90 is 34. The side opposite this 90 is 17. The side opposite the 1 tick is 16. The side opposite the 1 tick is 8. The side opposite the non-marked side is 30. And the other non-marked side is 15. If you reduce all of these, you're going to find that it has a scale factor. Well, depending on what we are trying to, if we are going from, first of all, are they similar? And they are. It's going to be a ratio of 2/1. Okay, so if we simplify that, so because they are all the same ratio, then the triangles are similar. So I could say that triangle, I'm just going to use ABC, is similar to triangle. A is the same as the F. C is the angle opposite the 1 tick, so I have to use, or excuse me, B has the 1 tick, and E has the 1 tick, and then C has nothing, and this D has nothing. So there's our similarity statement. So if I were comparing the 2 triangles as far as a scale factor of ABC to FED, that means 8/16, this would have a scale factor of 1:2. If I was looking the other way of a scale factor of FED to ABC, it would be 2:1. There's the clock. Example 2, looking at 2 rectangles. Okay, so if we are looking at the two rectangles, obviously all the angles are congruent, so now I have to check for proportionality of the sides. So, whoops, I forgot my measurements over here, which are 6 and 16. So if I look at my short side of my rectangle and compare it to my other short side, and look at my long side and compare it to the other long side, see if they are congruent. So I can either use the reducing and get 2/3 equals, if I put a 2 into both of those, I get 5/8. These are not similar. I could have also used the property of proportions. If I multiply across, I get 60. That should equal, that would give me 64. They are not equal, therefore also not similar. Last example. Oops, sorry. Last example, example 3. You have a figure within a figure. Okay, so if we are trying to find the value of x, and I have a side measurement of 20 over here. So the top would have to be proportional to the other top, so 16 over 24, and the side of the little one over the side of the big one. So I could do my means and extremes. 24x equals whatever 20 times 16 is. I'm going to take a shortcut because I don't have a calculator, and I'm going to just do the work. If I divide both sides by sum of this, so like 8, and that makes that a 3, and that makes that a 2. So now I have 3x equals 40. Divide both sides by 3, and we have x to equal 13 1/3. And that concludes that lesson.